Okay, first, before I continue, thank you very much for Chung-san. Excellent presentation. Your question about the failover is very, very important. We didn't really get to talk too much about it in the previous sessions, but all of these digital native companies are very focused on this idea of failure points. And usually, as the slides didn't show, but I know from where we've talked, you usually have multiple gateways or multiple endpoints so that when one fails, another one still runs. So it's a very good question. It's a very good observation. I need to take a picture of you. So I have proof that I was here. So I need everyone to say, hello. Very good. Okay. Now I can go home. They will let me go. Okay. So one of the things that I enjoyed about Chung-san's talk about ANA is that you had to change the way you did things, right? You had to think differently and change your speed and time to market and all these other things. And I love also this idea of forward to 2020, this idea of thinking ahead and focusing on something further on. And that's what we'll talk about this afternoon, these next few sessions. So this first one is about company culture. And company culture is a topic that we are asked about more and more by our customers. I began this business with computers, machines, engineering, math. Now they ask me about teams and motivation and communication and cooperation. This is a challenge for us. So we've done quite a bit of study in the last year or so about this notion of culture. And it's been pretty common for us to talk about. I was recently in Amsterdam. It was just last year, talking to companies about their culture and their environment. And I was visiting this museum. This looks like a boat, but it's really a museum on the bay, on the docks. And you can actually walk up the side to go up to the very top and look out and see much of Amsterdam from this view. It's really quite amazing. So I am on this modern building from the 21st century, looking to churches built in the 1700s. I'm spanning all these hundreds of years of history just looking across the bay. It's quite impressive. But there's another thing that I saw when I was there along the water. There's these rather strange devices, these rather strange tools. And I don't know what they're for. I'm told that they were very important for the shipping industry in the 1600s and 1700s. Pardon me. But they're rather peculiar devices, rather peculiar tools. And for many of us, we know that there are tools to help us create more effective teams and work together, but their tools are very odd to us because we're engineers. Often we would like just a single button to solve a problem. Can we all work together? Thank you, done. Let's go do some more. And I wish I had for you just a simple button. But instead, I want to talk to you about some tools. And these tools come in the form of some axioms or principles or laws about creating effective teams. We've learned these stories from Netflix, Amazon, Google, SoundCloud, Spotify music service. These are the things that we've learned in the last year about teams. So this is a research paper from 2009 by Microsoft Research. And they say that organizational metrics, the way your organization is designed, can predict software errors with a precision of 85%. Not the lines of code or how often, how many leaders, or how often you change teams, just the way your organization can predict the error in code. And there are many other studies similar to this. And in fact, as I mentioned earlier, before the break, a lot of this has been built into the way we think about microservices. So microservices actually depend a great deal on the culture or the teams. We saw Sam Newman talk about this in the last deck about Conways Law. So, excuse me one moment. I'm just getting past a cough. So, okay, sorry. All right. So we hear about this name, Mel Conway. And we saw a picture of Mel earlier, right? We talked about him. He's actually been a very busy man. Designed the first assembler for Burroughs computers in the 1950s. The first universal compiler, what we know as .NET runtime or as Java runtime, he invents the first one in 1958. First paper on coroutines for functions and methods and stacks and safety. And it's still today read by most compiler language developers. He writes an article, we talked about this article a little bit. Medical computing, he establishes the standards. He was an Apple fellow through the 80s. He's currently working on a new project to help developers improve their productivity without writing as much code. So many things that this one person has talked about, we're just going to focus on this one article that he wrote. By the way, you can visit his website. It's in the slides we'll send you. So this was one of the first projects Mel worked on in the UNIVAC system in the 50s. And this is when we used to build a computer to solve one problem. We didn't write the software, we just built the computer. All the tubes. And as we were doing this, he learns about this notion of project-based organizations. Organizations that come together to solve just one problem, to create one project. There's a whole business. We know project management because of this, because of NASA and IBM and all these other companies. They invent project management. So he writes this article in 1967 in this magazine called Datamation about how committees invent. And in it he says, he has this statement. He says, remember we talked before about organizations design systems that look like their communication. It's hard to understand this sentence. A copy of the organization's communication, or communication dictates design. The way we communicate. I think I'm going to need some assistance. Can someone find my suit coat in the break room? Please? I apologize, my throat is causing trouble. We'll be fine, we'll get through it. So this communication dictates design is called Conways Law. He didn't really name it Conways Law, but it was named Conways Law by someone else. Fred Brooks. Do we know this name? Fred Brooks, Mythical Man Month. Very famous book from the 70s. And in it, he quotes Mel Conway. And Fred Brooks is actually known for his own sort of law, Brooks Law. We might know this law. Adding manpower to a late software project makes it later, right? If I'm running behind and I add 5 more people to the team, it now takes longer, right? It takes longer because of the way we have to communicate with each other. This communication actually makes it harder for us to be successful. And Fred Brooks has a formula about this, which is a bit complicated. We don't need to worry about the formula, but it has to do with the way people communicate to each other. And he sort of explains it like this. If I have 5 people on the team, there are 10 different ways to communicate. If I have 15, there are more than 100 ways. 50 means 1,000, 150 means 10,000 different ways to communicate. That's really complicated. Thank you very much. I'm hoping there's some magic in this pocket. Yes. Okay. Don't go too far. I might need another one. Okay. I apologize that I have this in my mouth. I will try to be not so rude. But this model of communication tells us something very important. If I simply move from 5 to 15 people, I have 10 times more complications to communicate to my team. And at 150 people, it's very, very hard. Now, it turns out this idea about us being able to communicate to each other consistently was explained by a gentleman by the name of Robin Dunbar. Robin Dunbar is a social anthropologist from Britain. He studies communication patterns in primates. He says that brain size affects the size of your social group. The larger your brain, the more more people in your group. And he uses this as a model, and he comes up with what's called Dunbar's number. Has anyone heard of this Dunbar's number? This study affected the way Facebook originally arranged its network. Originally, Facebook used to limit the number of friends to 1,500 because they had read Dunbar's paper. Turns out it was a terrible idea. The way we work online is not the way we work in person. But his writing is very influential. 150 is the number he says is the most casual friends that we can keep track of in our heads. If I have 150 friends and I make a new friend with Chun-san, someone's got to go. Someone's out, Chun-san's in. Because they say our brains can only work this far. But I'm most interested in these groups also, not just 150. He has names for these groups as well. Intimate friends, trusted, close, and then our casual friends. So it turns out, what is the typical size in US of a startup company? 5. Close friends working together. And each one of these levels creates a challenge for creating and maintaining company culture. As a matter of fact, these numbers look very close to Brooks' numbers. We now can see why it's so hard to keep track of 150 friends, because there are more than 10,000 possible ways for us to communicate. Oh, do you know my friend Chun-san? Do you know my friend Otomo-san? You know, it's hard to remember. So communication dictates design. The way we talk to each other, how many people I need to explain, will affect our software. That's what's called Conways Law, and I say Conways First Law. It says that team size is important. And that means that we must keep teams as small as necessary to be as agile and speedy as possible. There's a company called Spotify. Do we know this music company, Spotify, that uses Dunbar's number and Conway's Law. They have squads. Each group is called a squad. This is a team of about 7 people. And together, they make up a tribe that all works in the same general domain or the same problem, the same challenge area. And that means that some people have a sort of a cross-team understanding. Maybe there's a designer on every team or someone that's interested in, that's a guild. Like I'm in the design guild and we can get together and communicate while I work on my team. So we have this sort of cross-information sharing. But it's based very much on each of these squads. So our first recommendation when you're managing your culture is if you do not have some relationship with every member of your team's probably too big. I've met managers and they've said, oh, who is that? Is that person on my team? What's your name? They don't even know who they are. This is a challenge to success. So we find companies over and over again have this team size of what we say Dunbar level 1 or 2, 5 to 15. Many of the microservice companies we talk to, the digital native companies we talk to, this is the way they organize. Small teams. And then they're loosely connected through their guilds. So it turns out there are other Conway laws in the same paper, which I think is quite amazing. So here's another tool that we're going to call Conways Second Law. So I love this law. There is never enough time to do something right, but there is always enough time to do it over. I think we may recognize this in real life when we say things like, that's okay, we can't finish it now, we'll do it in version 2. We'll do that feature later. Don't worry, we'll get a chance to do it again in 3 years. We'll rewrite everything again. Companies do this often. It turns out the challenge between getting things done on time and having all the features will always exist. These are trade-offs. I used to tell my boss when I was developing, do you want it correct or do you want it on time? What would my boss say? Both. So there's this interesting theory called efficiency, thoroughness, trade-offs. ETTO. In fact, there's a whole book about it. Very good book. From Eric Holnagel, who is in Scandinavia, and is a hero of the DevOps movement. He works to reduce mistakes in hospitals and life-threatening situations in his research, but most of the people who work in DevOps love Eric Holnagel, and he's a keynote speaker at many of these events. Why? Because Eric Holnagel talks about the decisions we make to make sure that the system stays up and running successfully without hurting someone. He has this wonderful idea that I have a difficult time explaining. I'm going to say these words. We talked about it with the translators, and I know it's a challenge for them. The difference between satisficing and sacrificing. So satisficing means it's just too hard for me to understand, so I ignore detail. I give up detail. Sacrificing means I just don't have enough time, so I'll get rid of some features. I'll give up something. So these two ideas are very interesting. If the problem is too complicated, I ignore details. It's really complicated to understand how electricity works, but I use it. I just ignore the details. Windows programming, Windows operating system is also very complicated. I don't understand how it works, so I just reboot. Right? I just give up. Never mind. When I want to get a project done on time, I give up some feature. So these are the two ideas. Give up understanding, give up on a feature. These are the trade-offs we make every day. We always do this because it's too hard for me to try to understand every detail. I don't really understand how traffic works, but I just drive to work every day. That's fine. So, what's really interesting is Eric Hollnagel uses some of these notions of the difference between ignoring details and giving features up in a thing he calls safety 1 and safety 2. Safety 1 means getting rid of all of the bugs so that the system is safe. Of course, we know you can't get rid of all the bugs, right? You never can. There'll always be bugs. He has another idea about safety that's built on resilience, which Netflix uses. They use this theory. You put as many things into the system to make sure that it survives even when there's an error. That's the idea of another gateway, right? So that even if this one goes down, the system will keep going anyway. As a matter of fact, Netflix is so dedicated to System 2, Safety 2, that they wrote a bunch of software that they call Chaos Army. Do we know this, Chaos Army? Yes, they write software that makes their own programs fail. So when they initiate a new server, they run software that turns parts of the system off or causes errors to see if the server will still run and still provide video without the buffer. They've actually spent millions of US dollars to develop tools to make sure that they end up with safety 2, because that's the most important thing for them. So thinking about safety in terms of its resilience, the ability to withstand failure, Hollnagel has a really complicated chart. I won't go into a lot of it, but he says it's basically coupling, which Chun-san talked about, loose coupling, and interactions, how complicated the situation is. For instance, up in the top corner, a nuclear power plant. One error, very bad, right? We know this, one error. This has happened here, it's happened in the US, it's happened in Russia. We know that this is really difficult. But there's also very simple systems like most manufacturing plants and assembly lines where I can just stop, and it's okay if I stop for a minute and fix the line and solve a problem and then turn the line back on again. It's much more loosely coupled. So we're making trade-offs between how accurate and how loose the system is. It turns out the real enemy for safety and resiliency is not understanding the details. We say intractability. I can't understand detail. And there's lots of reasons. Systems get too big. That's why we call monolith. So we create microservices to keep them small. Rate of change increases. People want features faster and faster and faster. Overall expectations rise. It should be Wi-Fi everywhere. It should be easy for me on my mobile. It should be everything. And this makes it harder and harder to understand. The way we can solve this problem is through continuous delivery in software. Continuous delivery in software gives us a chance to make a small change and improve step by step. So I don't have to understand the whole solution, just one part of it. If I make one bug fix and I install it and the system doesn't work, I know exactly what caused the problem. If I make 50 bug fixes and the system doesn't work, I have no idea what's caused the problem. So it must be one of those, but maybe it's two of those. Maybe it's three of those. Maybe it's only two of those when they happen at the same time. So all of a sudden it becomes hard for me to understand the detail. Continuous delivery means lots of small changes. Conway says the problem size is important, so we have to make the solution as small as necessary. Who does this well? A company called Etsy. These are the number of changes they make to their production system per day. 10 production changes a day. 30, 40 production changes every single day. At Etsy, they make 10,000 changes to production a year. We interviewed Amazon. They say if you count every configuration, every code change in every machine across all their regions and countries, in 1 year, they make 5 million changes to production. Small changes are easier to track. And that's why we have continuous delivery and continuous integration. Not because we just want to change faster, but because we want to change safer. If you or your team can't explain all the code in your release is too big. Stop. Don't do it. Make it smaller. Execute many small releases instead of a few large releases. Many of my customers still release maybe only 4 times a year. And it's the scariest thing they do. It's terrible. Some of my customers release once a week. A few of my customers release once a day. I have just 1 or 2 that release more than once a day. The ones, as you get further down on that list to a couple of times a day, much easier. At Etsy, first day you are hired, they give you the button. Your first day here, you have to deploy to production today, because that's what we do every day. So you have to deploy to production. Usually it's a terrible joke, and they turn the lights off, and they say, you broke it, but it's only a joke. They do multiple runs every day. Okay, Conway's third law. This is a word from mathematics. I had to look this word up. Homomorphism. It means there are 2 models that are identical to each other. There is a homomorphism between the organizational team and the software it produces. Here's the actual definition in English. Transforming into another set preserves all the relations of the first. They're mirrors. And this is the example Conway gives. He says, if you have a team of engineers, and then a team of people who program the system, and then a people who program the interface, they're going to produce 3 parts of the software. You won't get 4, you'll get 3. It says if you have 2 sets of services, that matches the actual implementation of the product as well. Here is another version that's easier from Eric S. Raymond. If you have 4 groups working on a compiler, you'll get a 4-pass compiler. If you have 3, you'll get 3-pass. The number of teams and the way they relate is the software you build. This leads you to the possibility of understanding the relationship between your teams and dependencies in software. Software dependency is actually a big risk, and it's an intractability problem. Understanding what software depends on what is really difficult. Because Conways Law talks about team interdependence. You want to make teams as independent as possible so they can release their software without asking for permission from someone else. If I have to wait for some other team to catch up before I can release my software, I'm in trouble. Because now your company can only go as fast as the slowest team. Sometimes we say the weakest link. If you hold a release until some other team is ready, you're not independent. This was another study by Microsoft about dependencies and being independent and releasing quickly. So they asked a team of about 80 or 100 project managers how they manage dependency problems. Some rather peculiar answers in here. Avoid unreasonable people. Cancel project. Done. Only interact with people I trust. Actually, I like these better, right? Minimize code dependency. Have a backup plan so you can ship without the dependency. Eliminate them. Never take critical dependencies. These are the techniques for creating agile software and for increasing the time to market. One of the things you talked about was this idea of having to close the window, right? Often creating a faster release or release more quickly doesn't mean we run faster. It means we travel a shorter distance, right? So if I only need to release one thing or one feature, that's a short distance than if I have to release 50. Okay. One more law. Doing pretty good? Oh, yeah, not bad. Okay. Disintegration. This is one that sort of adds up. So what Conway says is large teams fall apart faster than small teams. It makes sense. It's easy. And there are a few reasons for that. Because if the problem seems large, we'll put too many people on the problem. And team will be too big. We already know from Brooks' law that that's a bad idea. The second reason is that the way we organize the teams is the way the software gets organized. If we have too many subgroups, too many committees, too many meetings, too many memos, then the software doesn't work right. It doesn't fit together because of the way we talked about Dunbar. We can't keep all those things in our heads. Finally, because things are a mirror, are a match, as our team starts to fall apart, our code starts to fall apart. I think some of us have experienced this problem. You're working on a project and it misses deadlines, and it misses deadlines. And then eventually, you realize that the software you're working on is not even needed anymore. The company has changed. I'm working on a project that nobody's going to use when it's done. I've missed my opportunity. Every once in a while, we hear about this in the news, about a big failed IT project because it took too long to release. I experienced this myself in the last few months. I was working on a book project, another book project about writing client applications. And usually it takes me about 6 months to complete a book project. I was 3 or 4 months into it, and I had missed some deadlines. And I realized that actually the problem is much bigger than I thought. Oh no. I will never, the book that I was about to write was not the book that was needed. I have to tell my publisher, my editor, I'm sorry, I was wrong. We have to stop. So I have to stop, take a month off, redesign another book to solve the real problem, and then it took me 4 months. So it took a total of 9 months because I took too long the first time. So I think we all sort of experience these cases where sometimes you really wish you could just give up. We don't need this. Because communication is really the thing that dictates design. Time is against large teams and large projects. Time ticks away. We tell our customers, every day you don't release is a day your competitor can get ahead of you. Time is critical. So you need to make your release cycles very short and speedy. This is a report by the Standish Group. I love the name of this. They've been doing this for about 20 years. It's called the Chaos Report. They measure large-scale IT projects from size of small to large and from complexity from simple to complex. When the size and the complexity is small, you have a high degree of success. As it gets larger and more complex, it fails. It'd be very interesting. There's a URL you can read about these projects. They report every year on major failures of projects, and they analyze their size and complexity. So if you miss your release dates, your scope is too big. Make sure you can release at least once every 2 weeks, at least. Longer than that, and you're missing an opportunity. I have customers that release every week, some that release every day. It's very important. It's easier to meet this goal if you're a software as a service, because you update the service and everything else is fine. It's more difficult to meet this goal if you have lots of installations, if everyone has to update their phone or whatever like this. But many companies do it. It's not impossible. Google, Facebook, Microsoft always do this. Okay, so let's finish up this part. Conways laws can help us succeed because they help us design a culture where we can have great teams. So a system design is the copy of communication. So we need to actively manage communication. There is I'll just mention this briefly. It's a gentleman at AT&T who made some study about how we can improve code quality in teams, reduce the complexity of the code, and reduce the uncertainty in the team. And the way this is done is through improving communication. So, real-time chat. Almost every open source project has a chat room. Why? Because people are far apart and they want to increase the quality of the communications. PayPal has a rule that says all remote workers have to have a video conference link turned on. Not so they can make sure that they're there, so that it's easy to communicate with them. Most API teams use online forums or news groups in order to improve the communication. Most document using websites or wikis rather than difficult to update documentation systems, because it's much easier. You want to reduce the effort required to talk to the right person at the right time. Okay, second law, there's never enough time to do it right. We are continually repeating this process, so we don't have to worry about getting it right the first time. Jez Humble and his continuous delivery idea is based on the notion of making small, frequent changes that to reduce the risk, not increase it. He has this phrase. He says, if releasing hurts, do more of it. Do it more often until it doesn't hurt anymore. So support continuous process. Keep your changes small. Test as soon as somebody writes code, automate the test so that they know right away. Deploy as soon as the test passes. Don't wait. Shorten the feedback loop. It's easier for you to know when something's gone wrong when you just recently made the change rather than 6 months ago. So then there's this homomorphism, this idea about things matching and being the same. You want to organize teams to get the system you want, sometimes referred to as a reverse Conway. I'm going to actually organize my teams so that I get this software. And that's where Martin Fowler talks about microservices. He talks about rearranging the team in order to get software that's successful, organized around capability. It's not a project, it's a product. So this is his example. Most of us, many of my customers, they have UI teams, and they have middleware teams, and they have database teams, and they all have their own zone, and they have to have special meetings to talk to each other. Bad idea. What Martin Fowler talks about is taking UI and database and middleware and putting each of them on teams so they can create the software from start to finish. James Lewis talks about ownership. The team now owns that product. So organize by product or business unit, combine design and test and deploy all together, include storage and processes and UI all in the same release. Allow teams autonomy within their boundary. We'll hear from a Netflix manager in the next section about this one. Require teams to interoperate, not integrate. Remember the API where I didn't understand what was a business or an object, I just knew there was an API? That's how you can gain this speed in microservice, by just interoperating at the interface, not understanding what's inside. Make sure teams own the complete life cycle and they're independent. And finally, since large systems fail faster than small systems, keep your teams as small as necessary. And Jeff Bezos of Amazon has a story about this. He calls it the 2-pizza team rule. If your team is so big that it cannot be fed with 2 pizzas, you need to make the team smaller. Of course, those are American pizzas, so that's pretty big, right? It's not the little pizza, it's big pizza. So Jeff Bezos tells this story. He says you must make your team small so that we can move quickly. And he means small by Dunbar's size, 5 to 12. So make them small. Resist the urge to grow. Don't add more people. Consider Dunbar level 1 and 2. Be prepared to actually break up teams. When they get a little large, break them into smaller teams. It's okay. It's better to be too small than too big. You don't want to find someone who is on a team member and they have nothing to do. You want to find a team where everybody's working too hard. Can't we just get one more person? I just need one more person. No, I'm sorry. Okay. So here are the tools we learned from Mel Conway from a half a century ago, from 1967, almost 50 years. Increase communication, support continuous process, organize by product, and keep your teams as small as necessary. And this creates a company culture that can help you move quickly to solve whatever problems you have, whether they're APIs for inside or for partners or even for the outside. Okay?